Right. Now just see there all of you visible or not screen properly. Is it clear for everyone? Okay, good. Fine, very good. So today we are going to seeing this last concept. What is buffer solutions? In this chemical equilibrium, last concept we are going to seeing today. Last class already we are seen that ionic product of water. What is ionic product of water? What is common ion effect? Please kindly put in mute, ma. Please put in mute. Somebody noise is comes there. Mute all of you first of all. Right, fine. What is meant by buffer solution? So common ion effect and all, yesterday we have seen that one. Common ion effect. What is common ion effect and what is major? These applications are there that and all already we are seen. Hydrolysis of salts and the pH of their solution. Yesterday we are seen that. Right. Now today we are going to see that buffer solution. What is meant by buffer solution? What is the major use of this buffer solution means? If you are adding small quantity of acid or base to the solution means the pH of the solution remains constant, right? So that means if you are adding either acid or base, small quantity you are added to the solution means the pH of the solution remains constantly will be present, right? That means there is no increasing, there is no decreasing. Once if you are adding small amount of alkali or a small amount of acid you are added to the solution means the pH of the solution remains constant. That is called as buffer solution. So the best example what you are saying, for example, our blood is there. Blood. So blood is also contains some liquid quantity is presenting there. Right? Blood is also liquid is present or not? Our blood. Present or not? Blood. Yeah. If it is blood quantity is decreasing, water quantity is more will be there. What will happen? Humans are lying is takes place or not? Living or not? It is not possible to live, right? That means equal quantity. That means water how much is needed means sufficient. Sufficient quantity will be present in our blood also. Then only what happen? Humans are living is takes place. If only completely blood only will be present, me it is not lying there. That means by the combination of a small alkali is nothing but either it will be present, acid is present or base is also present in there. That means human body blood and all what you say pH value 7.8 something is there. That means neutral alkali. That means why when it is neutral is present, either small amount of acid or base is present along with the blood. That means water is also presenting there. That's why the pH of the blood is what happened constantly will be present. Just look at here once. What is how you are defining this buffer solution? What is buffer solution means? The solutions which resist change in pH on dilution or with the addition of small amount of acid or alkali are called buffer solutions. That means if you are adding small amount of acid or alkali is nothing but base. Either small amount of acid or small amount of base you are added to the solution means the pH of the solution will be constant. That means resist. Resist is nothing but constantly will be present. That solutions what you are saying means buffer solutions like that you are calling there. That means pH of the solution remains constant. So for example, see there. For example, if you are taking that, That means how much ratio means small amount of either acid or base you are adding there. Adik example, best example see there. A mixture of acetic acid and sodium acetate. A mixture of acetic acid and sodium acetate act as a buffer solution around pH value 4.75. That means acetic acid and sodium acetate, the buffer solution, what is the pH value means 4.75 will be present. And a mixture of ammonium chloride and ammonium hydroxide act as buffer solution around pH value 9.25. That means what you are adding means small amount of acid or base you are adding means what happened, the pH remains constant. That means in the pH value 4.75 is there, for example. And the buffer solution, what happened, there is no increasing, there is no decreasing. That means constantly will be present that value. So especially where you are using this buffer solutions and all means medicinal purpose and all you are using there. Medicines, drugs and all manufacturing purpose and cosmetic formulations and all you are using there. Medicines especially. Medicines and cosmetic formulations and all require this buffer solutions. Put in mute, put in mute first of all. Akash, right. That means buffer solutions, what purpose using? Constantly will be there. For example, medicine is there. That medicine tablets are present, shops and all. So the tablets and all what happen, manufacturing will be presenting from starting date to ending date. That means these in between days and all what happen, the drug characteristics will be constantly will be present whenever you are using. One day you are using or 2 days you are using, like that. That means that drug manufacturing and all what will be there means constantly will be there for a long time. For example, 1 month validity will be present, 2 month validity will be present, like that. So how this validity and all how we are fixing means by using this buffer solutions only, right? Tablets and all especially you're seeing, or else our cosmetics and all. This is expiring date will be present every item also. Either what are the substance you are taking, either soap you are taking, or detergents you are taking, or tablets you are taking, or eating food items you are using there. All these things and all what happens, some date will be there fixing there. So in that proper date, what happen means it will be constantly will be presenting there, right? That means pH value will be constant. For example, if you are not adding this buffer solution, what will happen? So whatever the tablets will be there, immediately what happen, either if you are opening me, immediately it will be spoiling nature will be takes place, right? That's why what you are adding means small amount of acid or base you are added to the solution means their pH value what happen, it will be constantly will be presenting. That is called buffer solutions. Next one. Kindly put in mute. Kindly put in mute all of you. Next one, see there. Solubility equilibrium of sparingly soluble salts. Sparingly soluble, what is the mean for that? Sparingly soluble salts is nothing but sparingly soluble. That means whether it is very fastly it will be soluble or very little it will be soluble, it takes place. What is the mean for that? Sparingly. Sparingly is nothing but what you say? Partially soluble. Right. So solubility means already we are seen previous classes and all. Solubility is nothing but dissolving nature. Solubility is nothing but dissolving nature. So best example, if you are taken one salt you are taken. Salt and all what happened depending upon the salts. Some of the salts are what happen very fastly it will be dissolving is takes place. Some salts are what happen it will take some time, right, for dissolving. So that means so that as water soluble salts also they will exhibit equilibrium. equilibrium state and all, it will be reaching is takes place. So when it will be reaching there and when it will be reaching mean just see there that and all. Right. The solidity of ionic solids in water varies a great deal. Some of these, like calcium chloride, are soluble that they are hygroscopic in nature and even absorb water vapor from the atmosphere. That means calcium chloride and all is there. For example, naphthalene is there. This and all what happen? They will immediately they will absorb moisture. Moisture is nothing but from atmosphere onwards. What happen? Water vapor will be absorbing is takes place. That is called as a hygroscopic nature and so on. That means immediately they will catch as water vapor from the air. So that's why what happen if your touches with somewhat wetness under you are feeling there. Right. That nature what is a hygroscopic nature and so on. Hygroscopic nature and even absorb water vapor from the atmosphere like lithium fluoride, others like lithium fluoride have so little solubility that they are commonly termed as insoluble. That means if your touches mean top and all what I'm somewhat wetness you are feeling there, but it is not completely soluble. Completely what happened? It's not soluble. Completely solubility is nothing but what you are saying. For example, salt is there, common salt is there. That common salt you are dissolving, pouring in some glass of water. What will happen? Immediately it is solubility is takes place. That means the salt whenever you are pouring in that glass of water, you can't able to seeing after or 1 minute after you are not able to seeing mean that is completely soluble. Like this naphthalene and all, what happen if it is absorbing moisture from the atmosphere? What happen? It somewhat it is wetness will be present, but is not completely wet. Completely it is not soluble. That is what is an insoluble substance and so on. Right. The solubility depends on a number of factors important against which are the lattice enthalpy of the salt and the solvation enthalpy of the ions in a solution. So the solubility and all what happen it is depends on two factors. One is enthalpy of the salt. Depending on the enthalpy of the salt, it is depending there. And another one what happens? Solvation effect. That means the solubility nature. Depending upon two factors. One is nature of the salt. Another one is solvation, whether the salt is able to dissolving in solution or not. The two factors it is depending is takes place. For a salt to dissolve in a solvent, the strong force of attraction between the ions must be overcome by the ion solvent interaction. That means mostly what happen if any salt you are dissolving in a solvent is nothing but water means they will exerting strong force of attraction between ions. For example, sodium chloride only you are taking there. That sodium chloride and all what ions is exhibiting Na plus and Cl minus. That means any salt you are taken mean there are two charges will be present, positive charge and negative charges. So because of this opposite charges, what happen means they will exert some a strong force of attraction. Strong force of attraction is present between ion and the solvent. Ion is nothing but positive ion and cation. Negative ion is present. And another one solvent. Solvent is nothing but what you say water molecule. Right. Solute, solvent, that and all where you are studying mean that is already ninth, sorry, or lab 12th standard you are learning there. Solution one chapter is there. What is meant by solution? What are the types of solutions are there? What is dilution? What is concentration solution? All these things you are learning there. Solution chapter. Here, what is meant by solvent? Solvent is nothing but so solution is nothing but there are two components is present. One is solute and another one is solvent. Right. Solute and solvent is combining mean that is called solution and so on. Adalo solute now what you say means smaller quantities taken means then solute. Larger component is present mean that is called solvent. I think best example salt is there. Small one tablespoon salt you are taking, one glass of water you are taking. And the table salt and all what you are saying means solute and so we call. Small spoon of sugar or salt. What you call? Solute. Solvent is nothing but large. One glass of water means quantity what happen larger than a. So larger quantity is there mean that is solvent. Small quantities present mean that is called solute, right? That means the intermolecular attractions are takes place between ion. What are the salt you are taken? That salt ions and solvent interactions are takes place. The solvation enthalpy of ions is referred in terms of solvation, which always negative. That means solvation. Solvation is nothing but ions and all how it is solubility is takes place in water. So that values and all what happen it will gives negative values will be giving. Why sir salt and all it is dissolving in water mean negative value it will shows means energy and all what happen mean releasing is takes place, right? Exothermic reactions are takes place, right? Because of this exothermic reactions what happen heat energy will be releasing is takes place. That's why what happen it will shows here negative values always it will shows, right? For example best example you are taking for example detergent is there, detergent powder you are taking there daily using the washing clothes purpose. And the detergent powder for example கையில எடுத்து தண்ணில நம்ம கை வெச்சணும் what will happen how you are feeling there? Detergent powder you are taking salt, right? Detergent and the detergent நம்ம கையில எடுத்து அப்போ தண்ணி போட்டு somewhat little water you are added what will you how you are feeling there? How you are feeling? Wetness you are feeling or chillness you are feeling there? Chillness, huh? Wetness, little bit wetness you are feeling there. Larger quantity you are taking and you are adding small amount of water you are adding means somewhat wetness you are feeling there, right? Like ice you are taken, ice you are taken and you are holding in hand. What you how you are feeling? Chillness you are feeling there. That means salts and all if it is dissolving in water means what happen it will produce it will liberate some amount of energy will be losing is takes place, right? That's why what happen means that salvation is nothing but salt is dissolving in water means always it will shows here negative values will giving there. Why means energy will be losing is takes place, right? So that is energy is released in the process of salvation. The amount of salvation enthalpy depends on the nature of the solvent. In case of a non-polar solvent, salvation enthalpy is small and hence not sufficient to overcome lattice enthalpy of the salt. Consequently, the salt does not dissolve in the non-polar solvent. As a general rule, for a salt to be able to dissolve in any particular solvent, its solvation enthalpy must be greater than its lattice enthalpy. So that lattice later may be overcome by the farmer. Each salt has a characteristic solubility which depends on the temperature. That means finally what you say means salts and all what happen means it is also depending upon the temperature will be takes place. Some salts are what happen without temperature also room temperature itself only it will be solubility will be takes place. Some salts and all what happen compulsorily heat must be need more than room temperature. More than room temperature some salts are here solubility will be takes place, right? So generally what type of solutions are which is solutions are it is depending is takes place solubility nature means just see there solubility and all which salts are easily soluble That and all see there. There are three category of solubilities are given, salts. Category 1, first category salts, how it is soluble means their molarity is, the solubility is greater than 0.1 molarity. M is nothing but molarity and so on. Molarity என்ன சார்னு கேட்டனா concentration and so on. Concentration expressing method. Molarity, normality, formality, mole fraction. This and all what you say means concentration of the solution expressing methods. That means solubility and all when it is more means the solubility is greater than 0.1 molar. 0.1 molar here greater than will be present means solubility will be takes higher will be present. That salts are soluble. 0.1 molar more will be present means that salts are soluble. Next second category. So the solubility value is less than 0.1. Solubility is less than 0.1 means slightly soluble. That's also all. That means the concentration of salt how much is there? Less than 0.1. Less than 0.1 will be present means that salts are slightly soluble. Next, solubility will be less than 0.01 molar. Third case, solubility will be less than 0.01 molar will be there means that salts are sparingly soluble. Right, sparingly solubility is takes place. So these are the three types of your sparingly is nothing but it is not completely. Yeah, not completely. Slightly is different. Sparingly is different. Solubility is nothing, completely it will be solubility is there. Slightly is nothing but only, for example, out of 80, 100 percentage only, or 80 percentage it is 80% or 50% it is solubility is takes place. Sparingly is nothing but compared to that very less. Less will be takes place. Less, very, very less. Right. So these are the three types of your salts. Salts and all solubility nature will be present. This is major important. So when the salts are soluble means the concentration of solution 0.1 greater than will be present means highly it is soluble. The solubility is less than 0.1 will be there means slightly soluble. And the concentration is 0.1 greater less than 0.01 will be there means sparingly soluble, very, very less. Very, very less, that means, right? These are the salt solubility in nature, right? Next one, see there, solubility product constant, solubility product concentration constant, how we are expressing, just see there. So for example, the taken here one solution is taken, barium sulfate, solid substance you are taken. Barium sulfate, what is the nature means solid barium sulfate you are taken. So the solid barium sulfate is dissolving in water. Water you are pouring, some little bit water you are pouring there. So how it is ionizing means barium 2 plus ions and a sulfate 2 minus sulfate ion will be forming. Barium ion and sulfate ion is forming there. So this equation is what is a reversible reaction. That means equilibrium state is presenting there. Equilibrium state is present. That means one is solid substance and next one is aqueous substance. Right. This is what is saying saturated solution you are taken. And the saturated solution while dissolving in water, what will happen? It will dissociate it into ions. Barium ion and a sulfate ion will be forming there. So this equation, how we are expressing equilibrium constant means, therefore concentration of product divided by concentration of reactant. So products what will be there? Barium ion and a sulfate ion is there. Therefore K is equal to Ba2 plus and SO4 minus 2 divided by concentration of barium sulfate. Here barium sulfate and all what you are taken, pure solid you are taken. So pure solid and all what happen? Concentration remains constant always. Therefore, you are neglecting this barium sulfate and all. Barium sulfate you are going to neglect. Why means it is a pure substance you are taken. So that's why that concentration what happen remains constant. Therefore, KSP is nothing but what you are saying means solubility productants only called. இதுக்கு முன்னாடி நம்ம பார்த்தாச்சு கேசி வேல்யூ நம்ம பார்த்தாச்சு கேபி வேல்யூ ஆர் சீன் ரைட் சேம் லைக் கேஎஸ்பி எஸ்பி ஸ்டாண்ட்ஸ் ஃபார் solubility productants only called KSP. Therefore, KSP is equal to K into BaSO4. That means Ba2 plus into concentration of SO4 2 minus. So that is called solubility product constant is simply what you're saying. This is a formation. Just look at solubility product constant like that you are saying there. Or simply solubility product, you can say that. At what temperature this is happening means the above equation is happening at 298 kelvins. That means the solubility product value what happened mean 1.1 into 10 power minus 10. 10 power 1.1 into 10 power minus 10. That means solubility product. That means the barium sulfate is decomposing means barium 2 plus and sulfate ions is forming. So during this reaction, what is enthalpy? What energy is releasing means solubility product. What will be there means 1.1 into 10 power minus 10. Right. How many reactants are there in this chemical equation? Mean there are two reactants are there. Sorry, two products are there. Barium 2 plus ion and sulfate 2 minus ion. Therefore, the total concentration of reactants will be equal to this constant value, solubility constant value. Therefore, 1.1 into 10 power minus 10 is equal to S into S. That means S is nothing but what you are saying. There are two ions is there, barium 2 plus and sulfate 2 sulfate ions. So that's why you are taken solubility. There are two ions you are taken, S square. Therefore, S is equal to overall what you are saying means 1.05 into 10 power minus 5. So this is what is saying barium sulfate solubility product. Solubility product what you are saying value means barium sulfate oda solubility value is 1.05 into 10 power minus 5 mole liter inverse. So same like that you are going to calculate. These are all experimentally calculated values. You are not taken here normal values, right? So all these values and all EPDs are under there. How we are able to getting these values are like that you are asking means letters is not visible. Voice is audible ma. Okay, right, no problem. Okay, no problem. Recording is happening, that's why. Right. So this is barium sulfate. What is the value finally you are getting mean? This is the value. So how we are able to getting this all these values means by using experiments only. Just look at here. Solubility values and all how we are able to get means experimental values. By using experiments only you are going to deriving these values and all. So we are not able to calculate easily. By using experimental only you are going to determine. Same like that another example is taken, that is a zirconium. Zirconium sulfide is taken there. Next one, next another example, see the zirconium sulfate, ZrSO, zirconium phosphate, sorry, zirconium phosphate, ZrPO4 thrice, ZrPO4, zirconium phosphate and so on. Same like that taken that another example. So this is what you are saying means solubility product constant simply. Next one, see the this is very important. Already I told you yesterday. These formulas are all very useful for you. Even the 12th standard or if you are going for some other purpose also very important. Chemistry is there means. So these are all what you are saying formulas. This and all salt is given, formula is given, and what is a solubility product. That means the salt and all at what temperature, at what equilibrium state it is solubility takes place. So these are the values. So silver bromide, what is the formula? AgBr. Next, silver carbonate, Ag2CO3. Silver chromate, Ag2CrO4. Silver chloride, AgCl. Silver iodide, AgI. Silver sulfate, Ag2SO4. All these formulas are very, very important. You have to learn formulas and the name of the salt. இது மட்டும் தெரிஞ்சுக்கணும் first of all. KSP value and இது தேவையில்லை. So you can't able to remember, no need this value. Solubility product value and all, no need. Just you have to learn these formulas and all. What is name of the salt and the formula and all, you have to compulsorily you have to learn this. Next one, see there. Last concept. Common ion effect on solubility. Common ion effect on solubility of ionic salts. So this ionic salts and the solubility effect, how it is presenting there. Common ion effect on solubility of ionic salts. Common ion effect, already we learned that common ion is nothing but what happen if you are taken same kind of two salts you are taken or two solutions you are taken means one of the ion will be commonly will be existing. That only, that's also you are saying common ion effect and so on. You are taken two solutions you are taken, and the two solution any one of the ion must be same will be presenting means that solutions and all you are saying common salt or common ion effect will be happening. That means two solutions also must be having at least one kind of atom must be need. One kind of ion must be need. For example, so acetic acid and sodium acetate is there. So acetate group and all what happen commonly will be presenting there. Right, that is common ion effect. If common ion effect, how it will be affecting for this solubility of ionic salts. Ionic salts solubility, common ion effect, how it will be affecting this takes place. Let us see that. It is expected from the Le-Chatelier principle. According to Le-Chatelier principle, this solubility of ionic salts will be depending this takes place. If you increase the concentration of any one of the ions, it should be combined with the ion of its opposite charge. So that means concentration of any one ion will be increasing means what happens means it should be combined with the ion of its opposite charge. Opposite charge kuda attack agum. And some of the salt will be precipitated till once again KSP is equal to QSP. Solubility product and reaction quotient, solubility both are what happen equal to will be present, precipitated. So reaction quotient and equilibrium constant, solubility product both are what happen, it will be equal to each other, both of them. That means the concentration of reactants as well as your reaction quotient concentration both are what happen, it will be the same, equal. Similarly, if the concentration of one of the ions is decreased, more salt will dissolve to increase the concentration of both the ions till once again KSP is equal to QSP. That means if you are adding here concentration of any one side you are adding there, one of the ion is decreasing is takes place means more salt will be dissolved. Concentration is decreasing, more salt will be dissolving is takes place. If it is concentration is increasing there, that ion what happen, it will be combining will be takes place with opposite charged ions. Therefore what happen, easily precipitation will be takes place, precipitated will be takes place. If for example concentration of one of the ion will be decreasing there, so what happen, more salt will be dissolving is takes place. The concentration of both the ions till once again they will approach here KSP is equal to QSP. This is applicable even for the soluble salts like sodium chloride. Sodium chloride especially it is applicable for this process. Right. Simple one இல்லம்மா. According to Le Chatelier principle என்ன சொல்றதுன்னா, for example, if you are taken here concentration of sodium chloride you are taken, right? Concentration of sodium chloride will be more will be presenting there. So more will be there means what happen? Opposite charges are what happen? It will be combining is takes place. Combining is takes place mean what happen? It will be precipitating is positive and negative like positive and negative. For example, NaCl is combining with water molecule. NaCl plus water molecule you are combining there. What will happen? Sodium chloride concentration ரொம்ப அதிகமாயிடுச்சு. What happened? Na plus Cl minus like the decomposing is happening. Water also what happened? H plus OH minus like the decomposing is takes place. That means the salt concentration will be higher. That means what will happen? Na plus ions and chloride ions are more will be presenting there. That means opposite charges what will be there, that charges and all combining is takes place. So immediately what happens? Salt precipitating will be takes place. If for example you are taken salt concentration will be less will be presenting there. You are taken concentration of salt will be less. One of the ion concentration what happened? Decreasing is takes place. So that means you have to add more salt will be adding is takes place. Right. Till the both the ions are equalizing what happen? You have to add more quantity of salt you are going to add it. That means in the two cases what you are observing means equilibrium constant concentration as well as reaction coefficient concentration both are equal. Both are equally takes place. So this is what is saying common ion effect and solubility of ionic salts. The given small example is given, just look at here once. They taken that solubility salts for weak acid is taken for example. Right. Just see there once. This example alone, just see that. Hydrogen halide is decomposing. What will happen? Hydrogen halide is decomposing mean H plus X minus like that decomposing is takes place. Therefore, Ka is nothing but equilibrium constant for weak acid. Ka is equal to concentration of product divided by concentration of reactant. That means concentration of H plus into concentration of X minus divided by concentration of Hx. Therefore, we want here concentration of H plus ion we want. Therefore, what happened? X minus divided by Hx is equal to Ka divided by Hx. So therefore, what you are doing there, taking inverse of both and adding